This conference will now be recorded.
All right. Thank you all for joining the Winnipeg MuleSoft Meetup. This is our very first virtual conference, and it's so exciting due to the COVID situation. This was supposed to be held in March, but we had to move this over to May, and I'm glad to get this started. So yeah, just uh, a quick housekeeping. Yeah, ensure to mute your mics as you join, and just to make sure, it looks like we have a couple more people will be joining in later on. Now we'll start right away. So a quick agenda just to get everyone up to speed with how the order of this conference is going to event is going to go. We'll have a bit of introductions here and some updates with regards to MuleSoft Meetup in Winnipeg and just MuleSoft in general. And then we'll get into the talk, designing for reliability, or achieving reliability, actually. I think that's wrong, but achieving reliability and best practices. And as well, there'll be time for questions and answers, and we'll have a game session, so to speak, because three attendees, three people from the audience will have the opportunity to get get a complimentary MuleSoft voucher training, and as well a certification exam voucher to write any certification of your choice. So yeah, I'm looking forward to that. It's going to be awesome. Okay. Just to make a note of that, obviously this is sponsored by MuleSoft Meetup, and as well as Narima Consulting has been a big supporter of the community here in Winnipeg, developer community in Winnipeg as regards to MuleSoft. So big shout out to Narima as well. And a bit of introduction from myself. I like to say in my former life, I was a training. I was an optometrist in training many years ago, before my conversion into computer science. I studied in the University of Manitoba here in Winnipeg as well after that. But anyways, I recently got my certification as a MuleSoft integration architect, which is exciting. And I also work as an application developer at Wawanisa. I've been writing MuleSoft applications since 2016. Prior to that, was writing more Sonic, again another middleware platform for writing integration applications. So using Sonic, which is by a company called Aurea. And I happen to be one of the co-organizers as well of this meetup in Winnipeg, and I'll be presenting at the main talk for today. I think as far as time is concerned, we have about a 30 to 45 minutes talk. So it's going to be, hopefully, want to keep it short and concise and go from there. And just a quick one as well. The MuleSoft Meetup Winnipeg, we have a Instagram account, so feel free to take a picture yourself and put it there, hashtag as well, MuleSoft Meetup Winnipeg. Yeah, you can feel free to give a kudos to me or add me on LinkedIn, and also as well sharing your professional and social network as well, what we're doing here in the meetup. Okay, just to make sure I I believe everyone can hear me. I didn't do a sound check or anything like that. I would imagine that there are no issues with, if there's any problem with, or if there are any issues with just audio or anything, feel free to put it on the chat or something. I'll be looking at the chat as my way of just knowing how everyone is doing, pretty much. But yeah, so feel free to add us and Instagram, and just to know what's going on in the MuleSoft community here in Winnipeg. Just a quick community update for some of you who may already know, and or who are not aware. We have there's a new release just this past this month actually, and the actual idea is to boost developer productivity, and it was announced in the Connect conference as well, the virtual conference, which took place I think sometime last week or so, which was good. Just to let everyone know that that's live. There are a lot of really cool stuff in this release that would boost the developer productivity. So yeah, you can check out the release page on MuleSoft website for that. Yeah, some of the highlights was Mule 4.3, as well as an upgrade to the Anypoint Studio. There were some really, some cool stuff that I like, especially in Anypoint Studio regarding the MUnit test creation, like a recorder to record tests. You don't have to like try to write all your MUnit test cases and whatnot. So I think that's cool. And just that integration between Studio and Design Center is quite seamless, I think. So yeah, there's some really cool stuff, just to let everyone know about that. And the MuleSoft Connect conference as well continues. There will be another one in June. So yeah, just sign up. It's free, and it's first of its kind to have the Connect digital. I enjoyed the one in May. I think I'm also gonna sign up for this one as well. So yeah, if you haven't signed up, there you go. And just to let everyone know, there is going to be a quiz, kind of like a trivia type thing. And when the time comes, I will, you know what, maybe I should just post on the chat. Yeah, when the time comes, I will let you know what the pin is. This pin isn't the right one, so don't try going there. But yeah, I'll give you further instructions when time comes. Anyways, just to let you know that that's coming. Cool. All right. Awesome. Right. So let's get the main talk started. Just quickly go to that link. Just give me a sec. All right. lot of stuff open. So just drag this here. Make this full screen. There we go. Okay. I hope everyone can see my screen. All good. If you can't, again, put on the chat so I know what's going on. But if you can, that's good. All right, so we'll just get right into it. This talk is going to be on just more architectural / design perspective on designing or writing a reliable integration application using MuleSoft platform. Just out of curiosity, who just trying to understand familiarity with MuleSoft or whatnot, like who here, if you can put in the chat, if you haven't, you know, if you have if you have experience with MuleSoft or reliability or anything like that, like if you have experience with MuleSoft, you can just put on the chat. And if you don't, I'm just curious to know what level of granularity I should get into as I explain some of these concepts. So if you can just put in the chat if you have experience with MuleSoft already, and just put in everyone so everyone can see that. Okay. See Mule Man. Okay, Suresh. Cool. All right. Yeah, that's good. Okay. Hassan and Rakesh. Okay, yes. There are a lot of yeses so far. Cool. All right. Cool. Thank you. I think a lot of my dealings in MuleSoft, a chunk of my work has been around just developing and designing MuleSoft applications specifically for reliability. For some reason, the non-functional requirements of from business users happen to be, I mean, based on especially when you have to write an application to process a couple of transactions that should go to a particular ledger or something, or a finance systems. You don't want to, you want to treat that quite delicate, right? But anyways, let's get to it. I have a quick funny meme here. That's me trying to make an app reliable 2,000 years after, looking like Gandalf. Okay, let's get to it. So the idea of this talk is, again, I'll try to just keep it I'll try not to go too technical and just try to keep it a bit more relevant and a bit more design oriented / architectural. We'll try to understand what the problem is with reliability, or what's the fuzz about reliability, why that is necessary, why should we even bother trying to develop a reliable application. And we'll use a use case. We'll kind of like build up on a particular use case, an arbitrary use case, and just talk on that, right? And then I would talk on what my approach towards design for reliability looks like, or what I think, some of the things that I've worked on as regarding reliability, and just wrap it up for questions. So so think about it. Oftentimes we get just think about this particular scenario. You just ship the Mule order management app into production, right? Go live was last week. Just imagine this particular scenario. And let's just say yesterday, front end systems for the first time processed like thousands of transactions. Okay, so this is the first time this application is live in production in your company, that kind of thing. Anyone want to take a kind of guess on what sort of questions you get from business stakeholders, right? So you just shipped a brand new shining app last week. If you can just put in the chat like what kind of questions. I mean, for those who have had maybe had experience writing a Mule application that is geared towards reliability. I mean, oftentimes I think it's quite important. It's quite funny. There are all kinds of questions that you get from business stakeholders or clients, right? Stuff like, well, I mean, okay, I see a couple of people. Well, what happened when my message errors? Is it recoverable? Yeah, that's a good one. And data is not reflected. I see a couple of people putting stuff in the chat. That's awesome. Found not picked. Yeah, there's all kind of questions. There are all kinds of unknowns. I just kind of like selected 3 so far that I've gotten. So did the transactions go through? Right? What happened last night with the batch process? That kind of thing. Can we actually replay the message again? Like, is this easy to do? Right? Because those are the kind of questions that tend to business users or maybe your operations people tend to ask. And those are crucial questions because those all tie in to answering the question of reliability, right? What's the need of writing a very solid MuleSoft application, putting it in production, and your user, and you can't, it's supposed to be a reliable application, right? And you can answer some of these questions. So the business user's concern does matter when writing reliable applications. So generally, when you hear of reliability or reliability, especially just reliability or in general, but I would just kind of like talk on reliability in MuleSoft or any integration platform. Usually you always hear of aspires for zero message loss or data loss after an application stops or crashes, right? That's what we want, or that's what is usually synonymous to reliability. Guarantees delivery of message transactions to end systems, right? Which is what it's supposed to do. Low tolerance for duplicate transactions. There are some for example, in an order, you have an order management application and you're writing a Mule application for that. You don't want duplicate transactions for certain things, right? There's just a low tolerance for that kind of stuff, and those matter, right? So this is what usually is what they say about reliable application, right? Right? Makes sense? But in the real sense, what I think reliability is all of that, all of what we just saw, and a little bit more. So let's take a look. What is what I think about reliability? I like to try to answer all these questions in my as I design or architect or develop the Mule application. Is it working as intended? You write an application, is it actually working as intended? Oftentimes it will work as intended, right? If you've done all your testing, your QA testing and UAT testing, and you shipped it to production, I mean, it's definitely probably working as intended if it got past there. But where the problem comes in is, will the application withstand unprecedented event or even predicted events? That's the part that starts to scare, maybe not the developer, but it starts to scare the business user, right? Well, what happens if something crashes? Also, application errors are self-identifiable. Are the errors actually, can anyone else aside from the developer who wrote the code go and look at the application, like have a way of actually seeing what errors actually happen, right? Those are key. So that's a question I like to try to think about as I go about development. Okay, so are users aware of issues? That's the next one. The fourth one here, are users aware of issues? And let's say there are issues, that's fine. Issues, stuff comes up every now and then, right? How easy is it to fix it? Is it even retriable? Is it replayable? Can you actually just go through that again and have it work? Let's say you have like batch or thousands or transactions pulling through, and something happened. There was an issue last night in production, and you have to fix them. How easy is it to fix them, right? That's a real question that I like to answer. Then, do you always have to check logs? I think that is usually our go-to way of figuring out if there's something wrong with an application or what happened. Well, let me check the logs, right? But do you really have to? So these are the over the course of this talk, we'll just kind of like touch on we'll just kind of like always refer back to this, because I tend to use this as a guideline when writing Mule application. And there's all kinds of ways to figuring out stuff. Like if this is, it's not limited to this, but I kind of like categorize everything under this. I like to answer these questions when writing a reliable application. All right, so let's talk about the main use case for this talk. So again, you've been given a mandate or you've been asked to develop a MuleSoft application or whatever, an integration application, and the business user wants, there's a use case, the business user wants to send an opportunity to a Salesforce backend, right? Hypothetically, we're just imagining stuff right now. Yeah. And so it wants to send an opportunity to a Salesforce backend. That's the end state. That's a target goal, so they can have better sales forecasts, something like that. Well, but before that, before the opportunity gets to Salesforce, the integration application should also do 2 database inserts, right? Why not? The user wants the integration application to do 2 database inserts to 2 separate database tables, and also do some transformation, and also do a lookup from a table or from a cache or something. This is the requirement. So this is the use case, kind of like just to get everybody on that. Makes sense. If I'm going too fast, feel free to slow me down. And hey, I'm monitoring the chat as I give this talk. So if you have any questions, feel free to just put it on the chat so everyone can see, and we'll try to answer them as we go along. All right. So having looked at this, just take some time to get that synced in, so everyone can just imagine this use case right now, because we're going to work with this as we go along. Okay, so Salesforce backend inserts to 2 different database tables, and it's obviously doing some transformation in the process, and in the middle somewhere it's doing a cache. It's doing a lookup from a cache. So, well, first things first, there we go. First things first, obviously you know the requirements, or you should know the requirements, and also what the opposing trade-offs are, because those are key, right? Understanding the trade-offs, the opposing trade-offs, and as well, go back, and as well knowing, if you're developing a reliable application, if that's what the user wants, if that's what you're being asked to do, I guess is our job, or the job of the architect or the developer, to make that well known that, there could be some performance degradation or whatever, latency, uh, having to write that kind of application, because the user wants zero message loss, zero tolerance, which is, it's almost achievable. Let's say 99.999 ish. We're trying to get up to that. In fact, we are trying to get up to 99 even. But yeah, zero message loss. In this case, in this particular use case, the user wants a zero message loss. We don't want that. Also, performance SLAs as well, service level agreement with the particular user or with the business user, understanding those, right? And making that known that, this is gonna affect performance, and what the transactional requirements are. Sometimes users will say, well, no duplicates, right? We don't want duplicates, especially if it's an order management system, or if it's, in this case, in our use case, is an opportunity. You don't want to have multiple opportunities of the same kind, of the same type, just going into Salesforce. That's going to mess up their forecast. So first things first, requirement trade-offs. That's key before you go along, because that is going to set the table for what you're going to do as you write the application. So when it comes to when it comes to developing reliability applications, oftentimes I think what's it called? This diagram here is in the MuleSoft reliability pattern website. If for anyone who has had to write any kind of application that supposedly reliable, is probably seen this or not. But for those who haven't, I would just briefly just go over this. So the idea is to avoid zero message loss. And this is just, I see this as a starting point, but let's just go over this. Well, the client sends a request through, from whatever it gets into, it's received by what they call a reliable acquisition flow. It's just supposed to be the entry flow that accepts request. And it receives the message. As it receives the message, it processes it directly into, in this case, a VM queue or a message queue. And the idea is that they're trying to keep the reliable acquisition flow as small as possible to ensure that if something goes wrong within the reliable acquisition flow, it's just going to fail back to the user and just say, hey, try again, or something happened, right? But as soon as it gets into the VM queue or whatever transactional transport mechanism you're using, in this case, oftentimes it's VM or GMS. Some people would use databases to do that, but VM and GMS are the most popular. As it gets into the VM queue, then it's a handoff. It's like washing the, it's like, okay, the Mule application is saying, I got this. It goes into the application logic flow and it does some processing, right? Pretty straightforward when it comes to reliable application. And the goal is that this pattern is supposed to help for non-transactional application. So in this case, this is a HTTP request coming in, right? Which doesn't support transactions. So you put it into a GMS or VMQ, and it's supposed to help out, because you could, whether you're using transient or in-memory VM or persisting it to disk, whatever it is, the idea is that if anything goes wrong if anything goes wrong to that message is not lost. It's within the queue, right? That's the understanding. It's within the VM queue or whatever queue, entry queue. But there are a couple of problems with this, right? Because if you want to actually do a reliable application, this is quite too generic, and I see that as what I'll say is starting. Oops, go back here. See that as a starting point to just designing a reliable application. It's just a blueprint. So just go in here first and just laying this out there. Oftentimes, when designing reliability in Mule applications, these are almost synonymous, or a combination of these help out, right? Until successful reconnection strategies, redelivery policy, retry exhausted, scope, and also transactions. Depending on how granular or how reliable you want your application to go, you can use a combination of this. I would show you in a couple of minutes here a couple of ideas about this, but for the until successful, usually, ideally you'd want to use that when you're experiencing a system error, right? A system error would be an error that is external to your flow or to your Mule application. Things like some like a database connection issue, things like if your end system is down, you want to use until successful scope, right? But you can't really use only until successful scope to make it reliable. Sometimes some people don't use until successful at all. I've seen until successful used very accurately to help out with that, but it does help to make it reliable and stuff. So far, these are some of the reconnection strategies are being set. I'll just talk on this real quick here for those who probably are not aware of some of these. Reconnection strategies are used in the connector, and the HTTP connector is just something that you set to reconnect if there are any issues in the flow or in connecting to the app. And redelivery policy, we all know that. For example, if something goes wrong within the flow, you want to be able to retry that. So all this just come out of the box in Mule, and a combination of it does help. Not all, but just wanted to lay this out there that this is like giving this talk, we're aware of this when developing Mule reliable applications. So let's kind of like go through that use case again. Remember, let's just take a look at the use case. We're trying to put in a Salesforce. We're trying to put in data into like a Salesforce backend, but in the process of doing that, we're supposed to insert into two different tables and also do some caching, right? So that's the use case. And if you were going to go with kind of like bare bones, or just someone who wouldn't have an idea of reliability or anything, you would just kind of like put a listener accept request, and there you can go as granular. I'm just putting this out there for just demonstration purposes. It's not fine to the teeth, but you get the idea. So based on the use case, yeah, you put in a logger just to see, log that something is happening. There's a transformation going on, probably for the impute request. Maybe it's coming in as JSON or whatnot, and it needs to it goes into the Salesforce backend as an XML, whatever it is. You have that here. You do your first database insert, cool. Okay, you do a retrieve cache, that's all good. You transform a message, do a second database insert, you just line it up like that, which is quite intuitive. And oftentimes you put this like this into production or something, it probably would work, right? It would work. I mean, as far as it can, it's just happy path, use case, create the opportunity. That's good. And case closed. But we all know that there's a lot of problems with this. There are a lot of things that could happen when you put something like this in a production, but it gets the job done anyways. Well, let's take a look at the second pass real quick. The idea of the second pass is for someone who took a look at the Mule documentation about reliability and is like, yep, I'm gonna just get this going. I'm gonna do a reliable application. And just to make mention, this is Mule 4. This talk will be demonstrating using Mule 4, but obviously you can use Mule 3. There are some slight differences with connectors and components, but especially error handling. But it also, the idea is just the design and how we'll go about designing that. So yeah, so you're trying to get this reliability pattern. Oops, I went to back. Oh, that's all right. Zoom out a bit. There we go. So now we have we now break it into trying to follow the reliability pattern. So the second pass Mule entry would be the acquisition flow, right? So it takes it the HTTP listener, which is largely synchronous, right? That's the idea. So it's executing on the thread. If anything happens, it fails back. If anything happens in between the listener and the publish to a particular VM queue, in this case is a VM queue, if anything goes wrong, yeah, it fails back to the user. And then it sends it to another endpoint, another VM queue that listens for it. Okay, and again, we have that use case, and the use case is to get data to a Salesforce backend system. And and so we transform the message, do the same thing that we did before, but we just broke it down into two different flows. This one will contain the application logic, and you can choose to put this into a flow reference or whatever. That's totally up. The purpose of this demonstration is just pattern understanding, understand the design pattern and how that could affect the reliability of the application. So looking at this, what could go wrong? There's still quite a number of things that can go wrong, right? Again, because we're trying to avoid zero message loss, so we're trying to ensure that the application is behaving as intended, right? And all that cool stuff, trying to adhere to functional requirements. So let's say it's doing the first database insert, and something happens, something goes wrong here, right? In this case, it had probably done the database insert already, and maybe there wasn't any transactional. I mean, there is transaction here, but the database, it has already inserted this already, right? And it goes to the retrieve cache. Let's say it goes to the retrieve cache. It inserts into all two databases, and it fails to insert into the create opportunity at the end system, right? So what would happen in that case is that depending on how you implemented it, if it has XA transactions or a local transact, just a regular single resource local transaction, what's going to happen is I mean, if it's XA transaction, that means our dependence is on the XA transactional manager to roll back the 2 database inserts and just roll that back so it doesn't commit. That's what could happen, right? But there's a lot of things that could happen with performance as well, right? Because now you're executing all these things on a single thread, and it's gonna have to, after this insert, it's gonna have to block and insert into retrieve cache. It's blocking again and inserting into this. It's cool, but there's some things that could go wrong. If something goes wrong, how easy is it to replay this flow? That kind of stuff. Those are the questions that I tend to ask. But that's the idea. Just wanted to run that by everyone. And then, oops, go back. Okay. Yeah. So how, again, we're just making reference to that blueprint sort of that I use. Application probably worked as intended, yeah. If it fails for a predicted event, is it reliable to catch that? Like, is the application able to handle, like, does the application have some kind of retry logic into that? Probably not. Maybe let's just say the application errors are self-identifiable. Let's just assume that there's the login was right there, but I didn't put all of them there. But if anything goes wrong, the user is going to have to check the logs to see what happened. If anything goes wrong, I can guarantee it's going to be time consuming to fix this, right? So here's the approach that I like to think, here's my approach towards designing an actual reliable application. It goes, I first of all put a lot of thoughts into that. Well, so obviously we're thinking about all the wrong things that could happen, first off. And whatever kind of application that we do, it's mostly doing it's either changing state or it's not changing state. So you look for operations that are doing read or get, or you look for operations that are doing post, insert, update, pretty much changing state, right? And then you build your application around those, because when it comes to when you have to now replay those, we don't want to do the same thing that we've done before. We don't want to insert twice. We don't want to do a post twice. We don't want to update twice. I want to do it in an efficient manner. In this case, the user isn't really too keen on performance. Let's say the user is I just need to make sure that this application is able to prevent zero message loss. Sorry, it has zero tolerance for message loss. So what I like to do is I break down the flows into what I call subatomic independent units, and I'll show you that real quick, which is quite neat, almost like it's sort of like a pattern. And let's say, this obviously, like this kind of application, you want to put it in if we're going to go to the API-led connectivity approach, which is what we should be doing. There are different biases to that, but for a particular application like this, would most likely be in a process API, right? And usually I've heard a lot of people recommend that you keep your process API to probably 2 to 3 different orchestration, or maximum 4. And by orchestration, I mean if you have to make a call to or external vendor in your process API. You want to keep that down and look for ways to keep that down in the span of your process APIs. Just keep it down to a lower number. That does help on a long run. But let's see what this is going to look like if we're going to break the flows down into subatomic units around those operations that change state in your flow. So let's take a look at this, for example. So hypothetically, again, we have a flow that is just logging and doing a caching, and it's inserting into database, doing a transformation in the middle somewhere. It's doing another insert, and it's pushing to an external vendor. Yeah, cool stuff, right? How I would like to break this down is here. Go here. Yeah, how I like to break it down into staged approach is I break it into 3 different stages. Why? Because we're doing an insert, and we're also doing a post to an external vendor or back end system, whatever it is, right? And excuse me. And yeah, so the idea is we want to ensure that if we have to do an insert, if we have to roll back an insert, we don't have to. We can choose to use XA or not, but it'll be nice to it'll be good to use XA for if you want to make it very, very reliable, XA transaction type. But if anything goes wrong in the stage 1, you can retry stage 1 alone, right? If anything goes wrong in stage 2, you can retry stage 2 alone. So the idea is a message flows in from the left to right. We just go through that. It flows in from left to right. It does a write into a database, and it hands off to a JMS queue or a VM queue. And I'll show you why I use JMS in this case. JMS is good in a lot of things and good and not too good in certain things. But let's say you're using any whatever IBM MQ or Anypoint MQ or something like that, or let's say Active MQ. Active MQ is quite popular, right? You log it into a JMS broker here. Again, we're not concerned about performance. I mean, we're not too concerned about latency, but we want it to just be reliable. That's all that matters for now. Okay, it sends into the first JMS queue, and then the second stage listens on that particular queue. It writes into the second, does the second insert, sends it to another queue before pushing. And in a couple of minutes, I'll show you real quick why this is quite handy when it comes to reliability pattern. Because what's going to happen now is if something goes wrong in the second stage, for example, it failed to insert here, we don't have to retry. We don't have to retry from the start anymore. We don't have to retry and do the insert in this again. Yeah, Victor, you say you can create inconsistency. Create inconsistency within the 2 databases. Yeah, there's a potential to create inconsistency for sure. There's a potential to create inconsistency for sure. But now the idea is that yeah, thank you, Harry. Yeah, so you could the idea is you're still doing the same thing that you were doing before when you had a whatever a straightforward insert and insert and insert. It's still going to do this first before it does this, right? So that's why we use XA transactions as well. But I mean, something goes wrong here, right? We really don't want to retry all the way from the start anymore. We can just retry this logic and it's still going to go through. Yeah, yeah, sure. Sure. You can always do rollback. Yeah, I can see a lot of chat. I can see a lot of chat there. That's good. That's good. But I'll show you what this looks like in code. And then I will show you why I use GMS here and how GMS can also answer a lot of these questions or for that. But this is just kind of like the idea, but I'll show you real quick. So let's go to, let's just see what this may look like in the code. I'm just gonna bring up, I'm just quickly gonna bring up this here. I just did a quick dummy implementation here just to show you what this would look like. Yeah, I'll show you what this looks like. Okay, so here I've designed a couple of applications, but because of time, I'm not going to go through all this ones. I'm just a couple of flows here, but I will show you here where. So first off, this is just a straightforward first pass approach, but that I discussed earlier. The second pass here is supposed to be like a reliability. It's supposed to be the Mule reliability pattern where you have this going, which is okay, right? You can roll back stuff. The database can roll back stuff if you have XA implemented here, right? Which is okay. Then and our dependence at that point will only be on the XA transaction. One other thing I want to mention is around this is just the fact that it's a long running transaction that we have here, right? And the second pass here, it's just a, oops, it's a long running transaction. It has to insert this and retrieve the cache before it does this and then does that and it does that. There's all kinds of stuff that could go wrong with this. All right. Now, although the staged approach seem complex, but I'll show you in a second. I've abstracted some things here for without going into in-depth details. But check this out. Okay, so the idea is that you've broken your flows into all the different writes that you do. There are two inserts here, right? Retrieving from a lookup would always you can always redo that, right? Without any issues, and creating and the back end system here. We've broken this down into 3 different stages, okay? And just go here. So this is the start. The third pass Mule entry, again, accepts a transaction. And as it accepts the transaction, it logs whatever, it adds a header. But there's something crucial. There's something called next stage, right? What this does is that it tells it writes on the message. Let's say in this case, I've used GMS, for example, and I've pointed this to an ActiveMQ backend here. And what's going to happen is it registers on a header next stage, right? And it writes that to a particular queue. And this is the start. This is kind of like our acquisition flow, okay? And then after it writes to that, it puts a particular header called next stage on the message, and it writes that to the first stage queue. Okay, and then the first stage queue is listening for that. And what this is doing is, again, is logging a header. Sorry, it's just doing a login here, and is initializing some variables. Any variables it needs to initialize is doing that there. And then it's doing only one database insert, right? It's just doing what it needs to do, and then it's just backing out. That's it. It sets the next stage header as well. Okay, and then it sets a next stage header and publish it to the second stage. So that next stage header is not just next, it's a header called next stage, but the value is the next stage that we actually write into. Okay, and then the third pass is simply the final stage, which is to create oh, sorry, this is the second stage. It's doing another insert as well, or retrieving from the cache. We can always retrieve from this cache, and it's just doing one insert, and it sends it to the next stage. That's just the idea, right? So it does just a quick write into the database, sets a next stage header on the GMS, and it sends it to the next stage queue. And the final queue does that insert into the Salesforce backend. Okay. But what is cool now is we have another flow whereby if something goes wrong here, we can send it to a DL queue, and we can automate that DL queue. We can add some logic to have that send back to an entry queue if we want to add extra retry logic. But the idea is that if we want to retry a message that failed in any of these stages here, we just put that into a particular entry reliability queue and do a header, and then it can send to any of these stages right here. It can send either to the first stage, second stage, third stage, where it failed. So it's not going to start all over again. If it wants to do if you're doing a retry, it's not going to have to start all over again. It can just start only from where it failed, right? Wherever it failed, it just has to do that. That's the cool thing about this header. So what this choice router is doing is it's looking for where was the next stage that message failed, and it's just going to retry that again. Just a really quick, neat approach, I think, to retrying this logic. So what happens is that now you can add transaction as well. You can add XA transactions to all this, to all your flows, and you can join those transactions together. I think MuleSoft has a transaction manager, Bitronics, to do that, which is quite just out of the box there. And you can just make all this flows a subatomic units that can just insert into its own backend, do that just one job, which is just insert. Okay. Now this may seem like a lot of work to do, but if we at the start of if we put in thoughts into that, this would quite make it fault tolerant, in that if something happens, we can either choose to persist the message, or GMS would persist the message, and we can always retry that again, right? This is just a quick show. There are some things that I didn't mention in that quick demo that I showed, things like just error handling. But the idea is that you want the error handling is key because it can direct after how many times you want to retry before, based on whatever error, if it's a system error or an application error, whatever it is. And I see Mule Man has a question there. Is there a reason to call the next? There's a question. Is there a reason to call the next queue directly instead of sending the message to the reliability after setting the next step? Yeah, that's a good question. Well, it's easier and is more straightforward, first off, to just send it to the next queue. Sending it to the reliability queue, it's also can also be done, but that would just introduce more latency to that, because you want to send it to reliability queue would have its own logic. And the idea of that reliability queue, if I bring that up real quick here, the idea of this reliability queue is to retry, if you want to be able to retry messages maybe manually, right? If you want to have to, let's say the business, something failed in the queue or in the application, and you want to be able to retry the message, the reliability queue is just there to either, if you want to automate your retry process, or if you want to just manually drag like thousands of messages into this queue, and it would just retry all of them to the stages that they fail, right? Here in here, I put publish to DL queue. You can publish to whatever queue you want, but the idea of the DL queue is that you can now drag. It's just messages that either have failed repeatedly after having like multiple retries and it failed, and you send it to the DL queue, maybe because there's a the end system, Salesforce end system was down for like a couple of hours, right? It's done retrying, and then you send it to the DL queue. You can easily just drag and drop that. That's the idea of this reliability queue, right? So that's the idea, right? If that makes sense. Then just to get back, there are a lot of things that using GMS and ActiveMQ just helps out of the box, and you don't have to, because again, you want your user or your operations people to have visibility into what happened, right? Oftentimes, I mean, I've seen people, add custom code in here to either, let's say, for example, the message comes in here, they save it to like a Redis cache or an S3 bucket or a message DB before they process that, and then they have like custom code to retry from an S3 bucket. Like, you can do that, but the nice thing about GMS is you can persist this. Let's say in ActiveMQ, you can persist every failed message, and you can see that using any monitoring tool. For example, you could use Queue Explorer. I have Queue Explorer here, but it's really not doing much. You could use Queue Explorer. You could use all kinds of stuff. GMS does actually work with answering a couple of questions with visibility and reliability. Just go back here. Yeah, like I said, you can automate your retry process using DLQ. You can there are like custom things you can just do in ActiveMQ to automate your retry process. So let's say, for example, you've retried this messages a couple of times in your code, and then something wrong happens. You can have that message you can have the message in the DLQ get sent back into your entry reliability queue, and it just goes over again, let's say after an exponential amount of time. And I chose to use GMS and ActiveMQ here, or ActiveMQ in this demo, because you can view the message, you can view failed messages, right? using any existing monitoring tool. There are quite a bit of them for ActiveMQ. And obviously transactions does help, right? So I think overall you can actually, the application will work for sure. There are a couple of things here that are may not work, but I think replaying the message isn't as tedious. It can be automated using this stage approach. You can just retry a message where it failed instead of retrying it from the start of the flow, which is really key. And you can, however you want, application errors can be self-identifiable because you're able to send certain errors, put it on the header, and just send it to the DLQ. And so you can also use the GMX to monitor queue depth if there are a lot of messages piling up in the queue that the users don't know about. Those are a few things that I think would help in just beefing up your reliability pattern. Again, this is just one of many, but there are all kinds of ways to go about doing it based on, again, functional requirements and whatnot. You don't want to use persistent VMQs for non-functional requirements that doesn't like duplicates, right? Because yeah, that could cause a lot of problems. Because persistent VMQs in Cloud Hub, for example, there's a caveat that you could actually have duplicate entries in there. So far so good. This is just a few detail. We're running out of time. I just wanted to keep this short and concise and just not too technical as possible. Are there any questions so far? I know there's been a back and forth here and with Harry and stuff. I see that, and I hear you, man. Like, there's all kind of ways to go about doing this. But yeah, are there any questions? Any like comments? Like, what kind of reliability pattern have you used in your day-to-day activities? Does anybody want to just make a mention of that or something, or put it in the chat or something like that? Has anyone used this approach before? All right. All good then. So, oh, just in training, Suresh. Okay, cool stuff. Cool stuff. Yeah, no, thank you all for listening. Okay, how to handle system errors as part of message loss. Okay. Again, okay, let's touch on Ramesh. So Ramesh said how to handle system errors as part of message loss. What I'll do is it goes back for system errors, goes back to your reliability. I'm sorry, your error handling pattern, right? What I've done in the past is I would again, this I can show you, but Mule 4 does it differently. The error handling in Mule 4 is slight different it's quite different from Mule 3. But you can custom, let's say for example, you can set this to look for that. If it sends it to, you can have one particular error, main error handler flow? Sure, Ramesh. Yeah, sure, we can. Would have this slides on the Mule Meetup on the Mule Winnipeg website. But yeah, so just to go into that, what I like to do is I like to tag system. It's kind of like separate depending on what, if I'm calling a database or I'm calling a backend system, there's a 404 or something like that. I based on my era, I would add sometimes depending on how it was, I don't want to retry that immediately. Again, you can use until successful if you want to handle system errors, just to retry it real quick, or for system errors, I would just like tag it or have that directed to the DL queue, right? And just have it put in a DL queue, because if it's retrying immediately, that if the system is down, let's say for example, for a system error, you've retried this 5 times. For example, this create opportunity state, you've retried it 5 times. You don't want to retry it again because it's probably down and it's going to take a couple of hours to fix, right? So you send that to the DL queue and have that automated. It goes on to the error, it goes back to the error handling. And then got another question here, Harry. I'll just quickly take that. Streaming reliability. I like to use batch processing. Again, depending on how much load that I have to process, I would use batch process to just instead of having to do this into stages, I'll just use batch processing to process any kind of like load of data that involves streaming. That makes sense. Okay, we're running out of time. We got to do the trivia. And yes, just for everyone to know, we'll be putting this on the MuleSoft Meetup page, the recording. I could also share this link with you as well. Blah, 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 Yeah, I'll figure this out. And we'll try to put everything on the MuleSoft Meetup Winnipeg page, just so you can see it. All right, let's just quickly. Sure. Let's just quickly go to Kahoot real quick. I'm just gonna kick off a game. Just gonna quick kick up this game. Let's see. Oops. All right. Oops. Okay, so I'm gonna just quickly put the pin, oops, in the chat. Oops, no, that's the wrong one. Yeah, so right now we're gonna do a quick game. Let me stop sharing my screen. No, I still need to share my screen. Right now we're gonna do a quick game. Just give me a second here. We'll do a quick trivia game so that we can get our winners. Oh, there we go. Okay. So if everyone can go to the Kahoot.it and enter this code 3086771. Okay. Awesome. You see, we got 6 players. Ramesh, to answer your question, the certification, there will be three people will have opportunity to win a certification, a training voucher and exam certification from this trivia game. But right now there won't not the certificate, the vouchers won't be given to everybody, but just as 3 people. So I say we got 18 players. Okay, we're ready for this. We just wait a bit more time. We got 21. I'm about to start. I guess I could stop recording too.